So we're back again in 7.6. We're looking at parallel lines and transversals. So parallel lines are just lines that are parallel to each other. It means they have the same slope, has the same rise over the same run, the same rise over the same run. So these two are parallel lines. And I can move them around if it makes me happy. Back and forth. So what I'm going to do is I'm going to put a transversal through them. So transversal just means a line cutting through them. And just like last time, I'm going to put little dots in the middle so I can measure my angles. Now we're going to look to see if the properties have changed between the alternate interior angles, corresponding angles, alternate exterior angles, and opposite angles. So we learned last day that opposite angles, like this one, and its opposite angle would be this one. We're expecting those two angles to be exactly the same. So opposite angles are the same. But let's take a look at some of the other angles we might not realize are the same. So ADE is this angle in here. There's this angle in here. Let's measure the other angles and see what we can get. So ADF, we're going to measure that angle. And I get this. That's interesting. What about this angle in here? We're going to measure them and then we're going to compare them all. Were we expecting it to be 48.88? I think we were. They're opposite angles. Let's see what happens when I measure these angles down here. So I measure this angle right here. And we should notice something very interesting. When I take a look at this angle and this angle, they happen to be exactly the same. Well, they're said to be corresponding angles. If they're exactly the same, if I slid this down or slid this one up, what would happen? It would be exactly the same angle. So if they're corresponding angles and the lines are parallel, well, it makes them look exactly the same. Does it matter if I bring this one down? No. Does it matter if I change the angle? Are they still going to be exactly the same? Yeah. Well, I noticed something else too. That this angle and this angle here are exactly the same. Do you remember what those are called again? Angle on this side, angle on that side. They're in between these. They're interior, and on the opposite sides, they're alternate interior angles. If the lines are parallel, the alternate interior angles are also the same. Well, that's interesting. What about this one? Is its alternate interior angle going to be the same? What do you think? Was that alternate interior angle the same? I think so. Oh. And I noticed this angle and this angle are the same. Well, those are called corresponding angles. So alternate interior angles are the same, corresponding angles are the same, and these opposite angles are the same. So if it's opposite and then alternate interior, it makes their corresponding angles the same. That's only true in parallel lines. What if I measured this one? What am I expecting the measure of that angle to be? And why would I know it? There's actually a couple of different ways I can do it. These are alternate interior, so I know they're the same. These are opposites. I'm expecting it to be the same. What if I didn't see that those are opposite? I could see that these two angles are also corresponding. And in parallel lines that are cut by a transversal, these angles are the same. I got one more angle left. And what do you think it's going to be equal to? $131.09. That's because it's corresponding here. It's opposite there. Now there's one angle we haven't talked about yet, and that is the opposite exterior angles. So remember what exterior means. It means outside of these two parallel lines and on the opposite side of the transversal. Look at those. Opposite exterior angles are also the same.